In this video, you'll learn how to multiply rational expressions. The steps you want to take for multiplying rational expressions are factor the numerators and denominators completely, state any domain restrictions, cancel out common factors, and then multiply the remaining numerators and denominators. For the first example, I'm just going to start by factoring my numerators and denominators, so focusing on just this portion for now. In the numerator, I cannot factor anything out, so I'd be left with 3x plus 1. In the denominator, I can factor out 4x from both terms, and so remaining I would have x plus 1. Now focusing on my second part, I want to factor the numerator first. So starting this out, I can factor out an x, and remaining I have x squared plus 3x plus 2. Factoring out my denominator, I can factor out a 3, so I'm left with 3x plus 1. Now, if I look at my numerator one more time, this can be factored a little further. So I'm going to do that next. So I'm going to rewrite everything else. So I have 3x plus 1 over 4x times x plus 1 times that x out in front, and then 3 times 3x plus 1 on the bottom. Now, this problem is an a equals 1 type factoring problem, and so I want to see what multiplies to be 2 and adds up to be 3. So that would be 2 times 1, so 2 times 1 is 2, 2 plus 1 is 3. So these new factors are x plus 2, x plus 1. The next thing I want to do is focus on my denominators and write any restrictions that occur. So I see from this piece, x could not be 0. I see from this piece, x cannot be negative 1. And I see from this piece, and if you need to still write out this work, that's completely fine. If you want to solve it, x cannot be negative 1/3. So there's all my domain restrictions. And then lastly, I want to go ahead and cancel out anything that can be canceled out. So if I look, I have a 3x plus 1 in the numerator and a 3x plus 1 in the denominator, so those will cancel. I have an x plus 1 in the numerator and an x plus 1 in the denominator. I have an x in the numerator and an x in the denominator. So remaining, I have x plus 2 in the numerator and 4 times 3 on the bottom, which is 12. So for this example, we want to start the same way. So step 1 is to factor all the numerators and denominators completely. 2x plus 1 cannot be factored any further. In the denominator, I can factor out a 3x from both terms. So I'm left with x minus 1. On the next numerator, first I can factor out an x, and then I'm left with x squared plus 2x minus 3. In the denominator, I can factor out a 4. And that leaves me with 2x plus 1. If I look through this one more time, I can factor this a little further. So I'm looking for factors of negative 3 that add to be 2, so that would be positive 3 and negative 1. So if I rewrite, I have 2x plus 1 over 3x times x minus 1 times x, and then the factored form would be x plus 3, x minus 1, all over 4 times 2x plus 1. Then I state any domain restrictions. So right here, x cannot be 0. Here, x cannot equal 1. And here, if I solve, x cannot be negative 1/2. Once I have my domain restrictions, I can start canceling out factors. So here I have a 2x plus 1 in the numerator and denominator. I have an x in the numerator and denominator. And I have an x minus 1 in the numerator and denominator. So if I rewrite what's left over, I have x plus 3 in the numerator and 3 times 4 in the denominator, which is 12.